All right, let's walk through example 6 on page 545. Remember that our goal is to get the matrix in row echelon form, which means that we want ones down the diagonal and zeros under that. Okay, so here is a system of 4 equations with 4 unknowns. So the way that we transfer the system into an augmented matrix is we put the coefficient for x, y, z, and w along with what it equals there. So they have done that. Notice if you have no x, x is 0. So hopefully you understand how we got from here to here. Now, making little notes on the side, they switched row 1 and row 2. Why is that? Because we want a 1 there, and we have that. Row 2, we can just switch those 2 up, that's fine. Now we're going to use this 1 in row 1 to eliminate the variables in the first column. So if we multiply row 1 by -2, and add it to row 3, we get this. Okay, so we're good. We got a 1. We've got a 1 here, and then now we have this is 0, this is 0, so we're looking good. Now they don't do this till later, but what you could do right now is we look at row 3, we want this to be a 1. So the way that we can do that is we can divide everything by 3. And they ended up doing it right here, 1/3, row 1. It's really nice because everything is evenly divisible by 3. If we use row 1 again, to eliminate the 1 here in row 4, we multiply everything in row 1 by a -1 and add it to row 4. So -1 times that plus that would give us the 0. -1 times 2 is a -2 plus -4 is -6. -1 makes that a positive, plus -7 gives us -6. -1 times 0 is just 0, added to -1 there. Don't forget here, -2. -1 times 2 is -2, plus that gives us -21. So do you see this row right here? Okay, we need a 0 right here in this spot. So we can use row 2, multiply that by 6, and add it, and that's going to 0 out that row. So 6 times this plus that would give us 0. 6 times 1 plus that gives us another 0. How nice. 6 times -2 is -12. Plus 1 is -13. Don't forget the constant. 6 times that is -18. Plus -21 gives us -39. So we're really, really close right here, getting to a row echelon form. We want this to be a 1. So hopefully you can see how you can divide both of those by a -13. And then we get here. Now, once we get here, what does this mean? Now we're going to do something called back substitution. Remember, this was x, this was y, this was z, this was w. So this tells us that 1w is 3, or in other words, w is equal to 3. I'm going to write that down. W is equal to 3. Going back here to our row echelon form, W is equal to 3. This was the Z column, Z. So we have 1Z minus 1W is equal to -2. Z minus W is equal to -2, but we already know that W is 3. So I can put that in, Z minus 3 equals -2, add 3 to both sides, and we get Z is equal to 1. So we're using something called back substitution to solve this system. Okay, let's go up to the second row. That's the Y. So we have Y plus Z minus 2W y plus z minus 2w is equal to a negative 3. Is that where I'm at? Y plus, yep, okay. So here's the equation that came from that matrix. I know that w is 3 and z is 1, so I'm going to substitute those back in. Y plus 1 minus 2 times 3, 2 times 3 is 6, is equal to negative 3. Y minus 5 equals negative 3. Add 5, and we get y is equal to 2. So we're almost all done. The last equation would come from row 1. So this is x plus 2y, x plus 2y. You could try this if you like, minus z, there is no w, equals 2. So we're trying to solve for x here. We know that y is 2, so 2 times 2 is 4. We know that z is 1, so minus 1. 4 minus 1 is 3, so we have x plus 3 is equal to 2. Subtract 3, x is equal to negative 1. And we have solved that system of 4 equations with 4 unknowns. I believe on the next page, example, I think example 8 might talk about a back substitution if you wanted to take a look at that one as well. Notice how they have the solution, x, y, z. Sometimes it's written like that. All right, thank you.